Hey, folks. Hello, everybody. How we doing here? You guys ready to get started? Awesome. So welcome to Cleveland Big Data, and again, we've got a really great crowd here at KeyBank Studios. If for those that are online, we've got 14 some people online right now. I'm going to turn my own volume off. Looks like we've got 14 people online. We've got a big crowd here at Key. So I'm going to walk through the agenda. So our agenda tonight, it's a standard meetup format, 3 20-minute talks. We've got Greg Orloff with recovering a plane from Lake Erie, Casey Stella with machine learning ops, and then Mike Onders is doing a big data mesh or mess. I just got a text. It's okay. Again, the announcements. So a standard part is always making sure people know about friend of the show. So a friend of the show is an honorific that you get when you do a presentation at Cleveland Big Data. It's yours to keep. It's yours for life. You cannot sell it or will it to your children, but it is yours for life. So if anyone has an interest in becoming a friend of the show, please let me know. Or yeah, you cannot make an NFT. Thank you, Carlin. You cannot make an NFT out of a friend of the show. If anybody knows anyone that would like to do a talk, if anybody has any topics, please hit me up. We're always looking for interesting topics or interesting new speakers. The January one's going to be we're aiming for another hybrid at Cleveland State. Cleveland State's offered to host it, so we're going to be back there live in January. A few announcements. I wrote a few ACM blogs that were getting a lot of attention. Data governance and the psychology of attention management, and also stack ranking organizational cancer. I think you can guess my opinion on the second topic. I'll move on from there. But in all seriousness, community announcements are also a big part of the meetup. We haven't been able to do it in person, so if anybody has any community announcements, any other meetups, anything happening in Cleveland, anybody got anything to announce? Anything? This is a for serious offer. Nothing going once. Bueller. So the next one is recruiting shoutouts. I did get a late breaking one from OCLC, our friends down in Columbus, who are the people that manage the Dewey Decimal System, and it's actually still an HBase. I'm not making that up. So that's the Dewey Decimal System is still managed in HBase in Columbus, Ohio. So they have an opening for a data architect. Any other recruiting shoutouts? Going once, going twice. Anyone? Cool. So we'll go. Oh, and a huge thank you, Cal and Pandata. Thank you for the pizza. KeyBank, thanks for hosting the meetup, and Linux Foundation, John Murdoch, for letting us use your Zoom. We literally could not do this meetup without you. And I have to describe this for the people in the room. Carlin and I and Cal were sitting at Case for the July meetup. There were 6 people in the meetup. You were here too. And so we were like, come on, we've got to do this. So first of all, I was excited to have 6 because my goal was 5, and we did 20% over the target with 6 people. And so that was the night we decided, like, we're going to start rebuilding the in-person community, because there was just a longing of for people to getting back together and meeting, but we were fighting some inertia. So again, thank you for everyone for coming out tonight. And a big round of applause for everybody, Pandata, Key, and the Linux Foundation. So thank you. And with that, we're going to kick off here with Greg Orloff. And Greg, I'm going to hand you the mic here. Oh, you got one up there? Okay, I'll just put it down here.
All right. Well, thank you, Doug, for that rolling endorsement here. Let me get closer to it. Can you hear me now? Yeah. How about that? Better? Worse? You guys hear me okay? All right. See thumbs up.
When you're ready.
Let me share my screen here. Give me 1 second. Guys seeing that yet, or? No, not yet. Okay. There we go. Now you can see everything. All right, hear me loud and clear. So thank you, Doug, for this invitation this evening to come and speak with the Cleveland Big Data Meetup Group. First disclaimer, I am not a data scientist, so I did stay at a Holiday Inn Express last night in order to prep for this. Well, you guys laughed at that. All right, great. Wonderful. Doug invited me to this event because we had a conversation several months or so ago, and I had the opportunity to partake in a fairly unique situation that I thought some of you that do dabble in the black arts and magic of data management and project management might appreciate. So, without further ado, let me kick into my next slide, maybe. Oh, there it is, down there. So, a little bit about me. I've got a fairly diverse background. I'm currently working with a local startup, IoT World. They're focused on the industrial side of the Internet of Things. So from our perspective, that's everything from energy to manufacturing to industrial control system cybersecurity, and then we dabble in smart big stuff, I always refer to it as. So smart city, smart infrastructure, smart building. I also do a significant amount of consulting work with private enterprises as well as government agencies. Just got wrapped up with a couple projects with NASA as well. I'm an engineer and a scientist by background, not a data scientist, but a scientist. I've worked in the high-tech sectors, low-tech sectors, launched 2 successful startups, also helped start 2 successful divisions of multinational corporations, not by myself, not single-handedly, but was part of that key recruited management team to kick those off the ground. So enough about me. Let's dive into, yes, pun intended, the topic at hand of rescuing an airplane from a lake. So several years ago, I was sitting in a Panera in Westlake, and I was having a bagel and a coffee, and my phone rang. And Bart called me and says, "Hey, what are you doing?" Bart was a man of few words. So I said, "Well, not really doing anything right now." Now you may think to yourself, who the heck is Bart? What is he talking about? So Bart is actually the owner of a corporation. It's called Underwater Marine Contractors. They dive in anything, and I'll leave it at that. It could be water, it could be liquids. You can see a lot of this stuff. But they specialize in underwater construction, demolition, contracting, anything where you need to get a process, a product, or something back online. That's what their specialty is. I said, "Well, hey, Bart, I'm not really doing anything once I finish this bagel and my coffee, so this is good. I'll be there in 10 minutes. So, okay, so Bart showed up. Now, I'm going to unpack for you what happened over the next 19 days of my existence right now. So the scenario that he called me about was corporate jet. I was taking off from Burke Lakefront and was lost from radar contact. It was late in the evening, and it was presumed at that point to have gone down somewhere in Lake Erie. Now, no one was positive yet. The conditions were harsh, I would say borderline abysmal, typical Cleveland weather in the middle of winter. We had about 40-mile-an-hour winds, whiteout conditions, snowing profusely. So that's kind of to set the stage for what we were looking at. Now, the event occurred actually a couple of days before we were contacted, and the mission was unfortunately transitioning from a search and rescue operation to more of a recovery-based operation. So we were there and we were faced, as the entire team, how do you find a plane? You know, how do you systematically approach something like this, which I think is something that you folks can relate to in any problem that you're dealing with from a data management standpoint. So the first step that this entire crew took was to establish a base of operations. Next step was to retain a series of experts, which was done, and we engaged most of the organizations and departments throughout the greater city of Cleveland. Fire, police, rescue, all of those folks were engaged, as well as we had several insurance companies. The National Transportation Safety Board was engaged as well, and of course the folks at the airport systems. So, you know, how do you start on something like this? It's easy to get overwhelmed when you're facing a situation like this. There's a whole lot of unknowns, right? Well, you start with what do you know? And that was kind of where we kicked off first. So, as I mentioned, we knew it was horrible conditions in the evening. Now, the plane took off, as you can see here, I think online and also on the screens behind me. It was westbound off of Burke. Went up into the air, got off the ground. It got off the ground in less than half the distance of the runway, which will give you an idea how fast the wind was actually blowing to allow the plane to get off. the next piece of the data that we had, it lost radio, and it actually never established radio contact, lost contact with the tower from a radar transmission standpoint. But we had several series of data points. Now, the complexity comes into this. We had longitude and latitude points, but we had conflicting elevations. So we had conflicting altitude data across these data sets that we had. There was data from the Plain, there was the data from Burke's Tower, and then there was also data from Cleveland Hopkins Tower. All of those were in conflict, excuse me. Now, one other lesson that you can go back to, I know we got some math teachers in the audience here, go back to middle school math, you need to make sure your units align, right? So when you're talking about various elevations or altitudes or however you want to phrase it, okay, what's our units? What's our reference point? Are we talking about lake level? Are we talking about tarmac level on the runway? Or are we talking about above sea level? So once we got all of that aligned, you still had the aspect of somewhere about a 300 to 500 foot conflict in the data points that we had. Now, you think about that and you start thinking about how long it takes a pebble to fall from 500 feet in the air, and there's a lot of time and a lot of runway space that you could possibly encounter to try and figure out where this was. Now, a couple other data points that had come up. There was actually a cell phone that made contact with a tower, so we had one additional piece of data, no altitude corresponding to that, but we did have a ping on there that we could also place on the map. So you're starting to see these data points roll in before we even started embarking on any type of an investigation. So what do you do with this data, guys, right? You're data people. So you have to start figuring out how do you build a model based on this. Now, what we decided to do is, you can probably see from that last slide that I had up here, in some of these sequential slides, we built this in Google Earth. So we built a 3D representation of every piece of information that we had. Now, the first step we took to actually go out and try and do something to figure out if we could actually locate this is we had multiple vessels within our control, our organization that I was working with at the time, and then we also had access to a lot of the other cities' assets. So we laid out a search grid, and we went out with a sonar approach. So what you're seeing here on the screen and on the screens behind me is kind of a grid map and a path of where we were taking the boats. Now, we had towed sonar array, we also had side scan sonar. What you're seeing here is the initial cocktail napkin, right? Most big data exercises start on a scrap of paper. They don't end up in R2-D2 right out of the gate, right? So something that I think people lose sight of a lot of times. Now, you're probably wondering, what the heck does a sonar scan look like? This is an actual scan, so this is what you're looking at. Now, to me, I think this looks like somewhere between a Mars rover photograph and an ultrasound. It could be on a baby or an organ scan or something like that. The complications you run into here is there is a lot of junk on the bottom of Lake Erie. And I would venture to say all of the Great Lakes, and especially Lake Erie. It's a shallow lake. You're right at the proximity of the mouth of where a lot of shipping traffic comes in and out as well. The other aspect that you have to look at in this is dialing in the scan width. If you know how sonar works, it basically, you're sending off a cone signal off the bottom of a vessel or a towed sonar array. That goes down. Now, the width of that cone directly and indirectly corresponds to the resolution that you're seeing. So the wider the cone, the less resolution. The more narrow the cone, the greater the resolution, but the more times you got to make back and forth passes. So the other piece that I'll add into this is when you do find something on a scan, like if you decided you want to investigate one of these little bumps on here, and you actually send a diver down, flash back to the conditions that I just talked about a second ago. We're talking 40-mile-an-hour winds. Lake Erie is usually running about 8 to 12 footers in that type of condition. And it doesn't resemble the Caribbean, much less Lake Michigan, very much from a clarity standpoint when you have the shallow lake that's churning at that level. So you're talking about at the most 3 to 5 inches of visibility. So this is diving by braille. This is not diving, looking around, sightseeing, or snorkeling like you might see. Once again, some Google footage here. The green that you see on here are some of the search arrays that we were doing over the first several days of this endeavor. The pins that you'll see up in the upper right-hand corner of the scan, those are corresponding to some of the other data streams that we were having coming in, because there was a terrestrial component to this investigation as well. You had wreckage that was starting to come ashore because of the wind conditions, the ocean current, or I should say the lake currents, not the ocean currents. So as these things started to flow, and this created a whole other aspect of data analysis and management, because we tried to back into location based off of current flow patterns. So we did a model of that. We also incorporated in wind flow patterns. So could you extrapolate back out from those data points washing ashore to where the point of origin was? One more approach that we encountered on this task. we still didn't have a good idea of what was happening to the plane. We don't know, if you go back to that elevation component, did they try to pull out at the last minute? Was there some other component? Did it veer left? Did it veer right? There was no information there to know. So we needed something else to give us a little bit more insight and more data to narrow our search, if you will. So a piece of that, the team kind of came up with the thought of, what about all the cameras that are located around town now, from a person of interest perspective? Most people don't like traffic cameras, but in this case, it actually, there was a serendipitous component to this because one of the cameras, actually the camera on East 9th, ended up pointing down East 9th out over the lake. So we actually had a signature. They went through a tremendous amount of footage to go back and figure this out, but they found a shot of the plane coming down on the descent, which basically told us it did take the path that we thought it was taking. Now, we didn't see where that path ended, but it was one more confirmation. Second piece of that is we had a telephone call that had come in and reported a loud noise. A West Side resident lived in one of the high towers had basically reported that they heard something that night, and the time signatures lined up with what we were talking about there as well. So bearing all that in mind, we were still kind of, I don't want to say coming up empty, but we were still trying to feverishly figure out what else we could do. Running in parallel with this, we were trying to discern what type of equipment was on the plane. You always hear the talks about black boxes and locator beacons and things of that. Well, those are standard, I think they're required operational components on a commercial airliner. It's an option on a private jet or something like this. So we had an amount of due diligence that was going on in parallel with everything I just talked about to get a hold of the manufacturer to say, okay, is it equipped with this type of equipment? Well, it turns out that it was. The rub on that type of equipment is it's connectivity based. So as soon as it hits the water, it starts to ping, and it'll send a sonar ping. We've got 2 weeks, roughly, give or take, depending on conditions, where it's going to send out a signal until either the battery runs out or the object is found. Now, the other rub on this is that you have to have a direct line of sight to the beacon, so to speak, and you need a detector to actually detect whatever it's giving off from a signal standpoint. So we got a hold of the folks at the government agencies that were tied into this. They flew a couple individuals out. They brought the detector. And our next course of action was, as soon as it arrived, we ran down to the lake immediately. They got there late afternoon. And of course, it's late afternoon here, right? And it's dark out already. So we wanted to pop it into the water. Did we hear anything? Well, we put it in, nothing. So we didn't hear a ping. Now, you're first kind of like, gosh, we didn't hear anything. Well, what does that tell us? That tells us that whatever is transpiring, if it's transpiring, is not inside the break wall. So that told us where the next leap was. So we waited for weather conditions. Now, once again, it was running 10 to 12 footers and heavy winds. We weren't going to get out there in the vessels that we had access to, so we called in a research vessel from the USGS, which is the Muskie. It's a 70-foot research vessel, moored out of Sandusky usually. So they came in, and that was the next course of action. So we got out there into these wonderful conditions, and the day we went out, it was probably about 14 degrees, running the type of swells that we're talking about, and it was snowing. But we dried outside the break wall, we dropped it in, and we heard a ping. So we got excited. At that point, we set up a triangulation system where we wanted to drop it in, and we had to figure out, based off of the way this detector worked, where is that object, right? So this is what we're trying to find, that roll of quarters, if you will. That little piece that I showed in that last slide is about the size of a roll of quarters. So you're looking in zero visibility for a roll of quarters at the bottom of a lake. So the way that this works, now I'm envisioning a flux capacitor, something of this massive piece of technology, right, that is just this AI invoked system. And this thing gets here and we unpacked it, and it looks like a bicycle reflector attached to a broomstick that plugs into a 1950s radio, a little ham radio set. And it's got these big earphones, right, which you can see on the guy in this one picture here. Now, the way that this magic worked is you had to aim the reflector. So you had to literally put this under the water, and then as you turned it, as the reflector lined up with the beacon, the volume would get louder in the headset. As you got closer, the volume would get louder, and as you turned away or you got further away, it would get softer. So we have this team of us on this boat, and now mind you, the freeboard on this thing is about 6.5 feet, so you can see the guy leaning over the side. This is Bart. He's the tall guy out of the crowd too. So he's got this thing in the water, the other guy's got the headset on, and I've got a compass. So we're trying to mark the direction so that we can correlate and then triangulate back into the centerpiece of this entire endeavor. So long story short, we spent a good bit of the day building a square around this and our best estimates on how we would triangulate back to that point. And set off back for home to make sure our numbers and crossed our T's and dotted our I's. So you can see the next day, the first dive we went down, Bart went down and he came back up with the flight recorder. So we found the pinger and the beacon. So that marked the first day of several days that we spent going through, the recovery piece of this and the salvage piece of this to see what else we could find from the plane. We had found various amounts of, I would call it, debris, if you will, or remnants from the plane. But so that's essentially the tale of finding a plane in a lake. A couple takeaway lessons from my perspective. To me, in these situations, the data stream is never complete. Okay, so you need to fight the urge of analysis paralysis and keep crunching numbers till you get the perfect solution, because the perfect solution probably isn't out there. Never underestimate the power of serendipity. We never would have thought that a traffic camera would have been a key thing to verify our data. The camera never should have been pointing where it was pointing. If it was operating correctly, it would have been pointing at the streets to watch the things. But when they had a power outage, those cameras fail, they go back to not zero position. In this case, not zero position was pointing out over the lake. And last but not least, oftentimes the human factor is the most critical aspect and even more important than the technology that we're leveraging to do these types of projects. So that's my talk. So thank you for listening and allowing me to be here today.
We've got a couple of minutes. Anybody have any questions? Anybody have another plane, maybe what they want to find?
I had a question.
Yeah,
hi, thanks. It was really interesting, and you led with a slide that said you had just transitioned from rescue to recovery. Once you switched to recovery, why the urgency to retrieve anything, given the bad weather and the risk factors?
It's a difficult question to answer. I think you have to realize that in a situation like this, there's a loss of life aspect to this. So there are people involved. It's not a server that crashed. It's not a piece of equipment that failed. There's folks that are caring. There's organizations that are caring, and so there's a sense of closure or a need to figure out what happened. And then from a preventive standpoint, you want to figure out if there is a way to learn from situations like this, how do you learn and glean information from that? So it's an unfortunate reality that you have to face. So.
I'm surprised there wasn't an oil slick that you would have found on the lake that would have helped pinpoint it.
Interesting question or nuance. I think from our perspective, think to the conditions though, and you got to remember this was a jet, so this is an aircraft that's probably traveling 300 miles an hour. So when it did ultimately impact, it would have I don't want to say self-destructed, but it would have fallen into a fair amount of wreckage. And then coupled with that, the lake conditions and the piece that I left out of here that I think I neglected to talk about was the freeze-thaw factor. So lake was hovering right around freezing point during this. So we had several days where we couldn't go out on the lake. So that coupled with high winds, high waves, it's not like an oil tanker or a station where you've got a massive amount of fuel or oil that would be out there. So that's probably the main reason that you didn't see it. Plus, no one was out there looking for that either. It's the middle of winter. Possibly in the summertime, different conditions, that may have been something that we could have leveraged too. All right. Okay, great. Hey.
Next up is Casey Stella. Yeah, bring it up there. That way you're also on the camera.
That beeping, okay?
Yeah, whenever you're ready.
I need to, oh, you just share the screen? Okay, cool. Hold on. Awesome. Can I get a 5-minute warning?
Yes.
Cool.
Yep. And just, do you want this thing?
Yeah, let me get that thing. All right, excellent. Hi, everybody. My name is Stella. I've been here before. You might have seen me, you might not have, but hello. I'm here from Stripe. So, infiltrating key bank, I guess. I am presently the Pillar Tech Lead for ML Infrastructure at Stripe. What that is that's what we call ML Ops. I'm referring to it as the more common name here, ML Ops. Another thing that's odd about Stripe is we distinguish between data science and ML engineering. So I will refer to these things in slightly different ways. When I say data science, when I say ML engineering, they're engineers who are building ML models. Okay, so I live in Cleveland. I did the startup stuff here with Explorus. A few people that I know from Explorus are here. I went to Hortonworks. The reason why I went to Hortonworks is because I was interested in figuring out the applications for big data technology, particularly in Hadoop. We were a heavy Hadoop user, an HBase user at Explorus. I was interested in figuring out how those applications were used. I eventually began sort of my open source journey, being a VP of an Apache project, Apache Metron, which was a cybersecurity-oriented ML application on top of big data. I left there and I joined Stripe about 3.75 years ago, and I joined the big data team effectively. But I quickly transitioned out into the ML infrastructure because really my belief and the assertion that I'm going to make here is that ML ops and ML applications are one of the best applications to build on top of big data stacks. And it's something we talk about a lot, but we actually don't see a lot of clarity. And the reason why is because the technology is catching up to the business. The business need is catching up to the technology. And we're starting to see that now. So this talk really is about a survey of what ML ops kind of looks like. And I'll give you my perspectives, very opinionated perspectives. Okay, so this is a cycle. This is the sort of the cycle of ML at any organization. The far left here, you have business and data understanding. This cycle is really about figuring out how to justify an ML application. Things that you might need to understand. Is the juice worth the squeeze financially? Do you have the data in order to actually support it? In there is sort of the initial prototyping of the model. In here you often see machine learning engineers and data scientists going through and figuring out what data do we need to add, what data do we need to refine, is it even possible, and is it worthwhile? Once you've figured out that it's worthwhile, then we're on to the development and operations. Okay, ML is far more like the scientific method than traditional software engineering. And that brings about it a really interesting aspect in that it's a little bit different. And what you're going to see here is a lot of the aspects of ML ops rhyme with data ops, but they're slightly different because the needs of ML are slightly different. Okay, you do the normal thing. You start with data engineering, figure out how, is your data good, is the quality good, do I have the actual data, do I need to add more data, et cetera. You go through ML model engineering, which is to say, I have a bunch of ML engineers, data scientists, take this information, take these inputs, train a model, figure out if it works, onto model verification. Possibly it's not, doesn't work, doesn't meet the expectations. You go back to data engineering, you do that inner loop there. And once you're out of it, you go on to the actual operation, the deployment phase. Most people, when they think of ML ops, They forget the left-hand side and they forget the right-hand side, and they focus 90% of their effort on the middle side. That is wrong, and it's going to result in a bad experience for you. Most of my life is spent in the right-hand side because we have 200, 300 models at Stripe, mission-critical, in the charge path models. If they go down, we need to figure out what the contingency plan is. If your fraud model goes down, you lose money. Talk about an incentive, right? Okay, so we'll talk briefly in this talk about what are the different aspects of, what are the different things that one could build inside of ops, or buy even. The first one is the one that's probably the hottest right now, if you want to talk in the ML ops circles, and it's a feature store. So a feature store is effectively the inputs into your model at the different phases are taken care of by the feature store. So generating training data. Do I want a year's worth of training data? Do I want 5 years worth of training data? Do I want sampled? Do I want that sampled? Do I want it biased toward recency but tapered off? All of those kind of things, you would interact with the feature store. Do I want to figure out what other people have used as in terms of features and reuse those? Tag them, have it slot into my lineage solution. Again, the feature store, okay? The other part of the feature store is the online aspect of most inputs, most features, what I'm talking about are aggregations. Mins, maxes, averages, unique counts, etc. Right? Those, the online aggregations, because again, fraud, right? Stripe, we think about fraud a lot. Fraud is extremely time sensitive, shall we say. You don't want to fraud, you want to be able to update, you want to have your model have the most recent information possible. So this is an online model. There's online aggregations, there's batch aggregations. You want to be able to unify all that inside of a centralized abstraction. That is fundamentally, in terms of big data architecture, a Lambda architecture. Most of these are built on top of Lambda architectures. Most of them are built on top of Spark or Flink in batch, and in streaming, it's bog standard big data application, but with very specific use cases here. Okay, so your options, probably the most complete, came out of Uber's Michelangelo, or Palette now, and they built a company called Tecton. You're a small company, go buy them. There's lots of issues and benefits. The main benefit being you don't have to think about building a bog standard Lambda architecture. A lot of people are this is really very popular. One of the more exciting things around MLOps in terms of open source projects, because my heart is still in open source very deeply, is that Airbnb has recently open sourced their version of this called Chronon. And when I say recently, I mean just a couple months ago. It's great, but it's incomplete. So they're slowly, you know how corporate open source works, so they're going to slowly get it out. Also, SageMaker has a solution to this. For the most part, they have punted on the aggregation and online compute aspect and focused on the serving aspect. That has its benefits and its detractions. Most of the time, if you don't need online, you're good to go with SageMaker. It's perfectly fine, and you get that good, juicy SageMaker ecosystem. But if you don't want to pay Jeff Bezos that much money, please, by all means, build your own, which is fine. Build on top of Chronon, or buy Tecton if you have that online need. Okay, so considerations are streaming or batch. Batch is easier, streaming is more complicated, but streaming may give your model a boost. We have found that streaming gives your model a boost, especially in the fraud aspect. We found that, you know, almost universally. The computation full and computation free is really about, you know, SageMaker. So next, we're going to talk about orchestration and training. Okay, most of your ML engineers and data scientists will use the notebooks for the most part. I'm not talking about notebooks. I had a whole talk about notebooks. Notebooks are done. Use them, please. Whatever notebook you like Jupyter, you like Databricks, love them, use them, wonderful. At some point, you will need a repeatable directed acyclic graph of operations that you can stitch together and make it repeatable. And the reason why is because the best way to automatically update your model is to auto-train your model, is to automate. That way, you're always presenting your model with the most recent data. Train every week, train every 2 weeks, whichever you want. But the point is you want to be able to set yourself up to do that training, and that means building. That means you can't do everything inside of a notebook for the most part if you want to maintain your sanity. Again, opinions. Okay, 2 options really, both of them open source. Airflow, everyone's got Airflow. Look around, you probably got it under your organization probably has it under a bed somewhere, tucked away in a corner. Flight is the new hotness. And why? What is the difference? What has Flight done? Flight has Git-like semantics so that you can fork your flows and push them. It's containerized from the start, which means that you can do GPUs on Flight. It means that all of these are in Python. Python is king in ML infra. Anyone who tells you that your data scientists and ML engineers will do Scala is lying to you. Please fire them. Just kidding, don't fire them. But please don't make that mistake. Good Lord, I've lived that mistake a few times in a few different companies. Distributed versus non-distributed. Okay, do you need distributed training? Do you not need distributed training? When I say distributed training, I mean one model, many machines, right? For the most part, unless you're building a really big, really deep model, you don't need it yet. And if you do, bake in integration into SageMaker from your orchestration system. That's my opinion right now. In 3 months, maybe it'll change, but that's my opinion right now. You probably don't need it unless you're building. You know, if you're building the next DALL-E or one of the big image generation models or something like that, by all means. Okay. Next, the boring thing, which is prediction serving. ML models are API or remote procedure calls that are immutable. It's a normal big data application. You want to use something like Kubernetes. Like most of these solutions rely on something like Kubernetes to give you a container, to create an API. You do your training. You present you wrap the outputted model in some API that will allow it to serve predictions from it. It will interact with the feature store, or either the training system will interact with the feature store, or you'll interact with the feature store to get the inputs and then present it. Tons of different ways to do this. This is mostly a solved problem. What we found, however, is that if you want this in the charge path, and we have things like, we have around 50 milliseconds budget to get the features and train the model. When we're talking about TensorFlow models that are deep models and things like that, that's extremely tight. And 50 milliseconds at P99.9, right? Super tight. We actually needed to build our own version of this that would allow you to build a TensorFlow model and run it in the JVM. So what you're going to have problems with is the tension between ML engineers and data scientists wanting to use Python for everything. But really, probably the best piece of engineering in software in my professional life has been the JVM. I hate to say that, but it's the truth. It's amazing. It's very fast, and I can tune the hell out of it. It's a lot harder to tune Python raw, but sometimes you need it. Probably you need both. I think that this is probably the easiest to understand bit of kit in ML ops, but it's also the one that almost everyone gets wrong at the edges. So, big opportunity if you want to build an open source project. Okay, there we go. So finally, that right-hand side, here. The ops. How do you know if you need to retrain? Model staleness. So ML ops has the same kind of thing as data ops, which is you want to monitor, you want to measure. The difference is what you want to measure. You want to measure the distributions of the data coming in, and you want to measure the distributions of the output of the model, and you want to flag whether or not there's anomalies. Sounds easy, pretty freaking hard, actually. Turns out anomaly detection is a hard thing to do. You often get it wrong, and ML engineers are really pissed off if you wake them up in the middle of the night for a false positive. There's some options here. Common ML being one, weights and biases being another for experiment tracking, and also rolling your own. Here I recommend keeping it simple, focusing on data monitoring, and then letting your ML engineers build custom pipelines for this that are specific to the model. That I think works best because they own it and they have skin in the game and they won't be pissed off when it pages them. Just enable it. That means exporting data to places like Presto, which I'm a big fan of, by the way, or Hive, whatever. Okay, so we have 5 minutes, and I will talk very briefly. Actually, you know what? I'm going to spend the 5 minutes. Does anyone have any questions? And if I get no questions, I will punish you all by giving opinions on each of these points. Sure, hit me up.
Yeah, it's more around like data governance and sort of how, obviously at Stripe, you must have confidence in the data to bring it all into the model.
No confidence in data.
So what are you giving back to the organization once you've sort of sanitized that data? Can it be reused? Just kind of curious if there's a relationship there with your data architects.
Yes, it's a good question. Do you have confidence in the data? So here's the challenge. Sometimes the kind of refinement and massaging of that data that's required for ML models is not necessarily as useful for the organization at large, because ML models are different than humans. They seem like little babies, but they're different than humans. They whine as much, I'll be honest. But yeah, so you generally want to bake in at the ML engineer level what they want. Like if they have a data set that they want to build on top of, they will slide into your data catalog and data lineage solution. That is largely upstream of us. We have specific needs in terms of data quality as well that you often find as part of your training data, right? And things that run in flight or Airflow on a daily basis. Any other questions? Tough crowd. Okay. Where does data ops end and ML ops begin? ML ops is built on top of data ops. In my opinion, you have to have a solid, in order to really do this well, you need a solid data ops stack. No one has it, so you just do the best you can, and you fill in where you can. We're still figuring it out at Stripe, and we've been around for 10 years, or at least. All right, staying out ahead of the curve without a big crew. From a business perspective, how do you buy? Buy versus build. How much do you buy? How much do you build? I think that you want to make, if you have specific needs that are outside of what SageMaker and Tekton can give you and things like that, you might need to buy. Make your bets well. Focus on the thing that actually will give you measurable value. Having models in the charge path was extremely important to us, so we invested. We were early, so we invested in our own feature store early on. You can see talks about that from 5 or 6 years ago from us. What you will find is bake into this the notion that you will have to rebuild every 3 or 4 years, because the industry will outpace you. Open source will outpace you, and industry will outpace you. All right, last minute. That's about it. Thank you very much for your time. Oh, prototyping in production. Okay, look, ML engineers want things to go fast, but doing that, there's a lot of friction between doing things entirely in Python really fast inside of notebooks. You need to make it so that you have an orchestration system that is easy to use and fast to prototype. Otherwise, they will go off and do something in a notebook, and then you will have to hear about it. And you don't want to hear about it because it's painful when you do. So it is good to focus on user experience, and it's the one bit of the big data stack where it really makes sense to focus on the user experience up front. This is not something the big data technologies generally do. All right, that's it.
And last up is Mike Onders, who's going to be talking about big data mesh or mess.
How many people know the term data mesh? All right, at the end of the talk, you can all raise your hand. Right. Up. All right. Here it is. So just a side story. It's a small world. My brother knows the family that was on that plane that crashed into Lake Erie. They used to live in Cleveland, and they moved to Columbus. And the sad part of the story is they flew to Cleveland to go to a Cavs game. It's only a 2-hour drive, right? And they decided to fly back in the middle of a storm when they could have either got a hotel or hopped in a car and drove back. And part of the reason they searched was because there were people in the plane, right? They had to find them. But so I'm going to talk about big data mesh or mess. And the other thing is, I used to work at Explorers. The Explorers alumni are sitting like right there, and the key bank data team sitting over there. And I left Explorers, hard to believe, 9 years ago. So I've been at Key almost 9 years, hard to believe. And I chose this talk because in January of this year, we gave a talk on, we were migrating all of our Hadoop data and Teradata data to Google. So I'll give you a quick update if you weren't here in January, but I didn't want to spend the time on that. And we're a little bit bigger than Stripe, and we're not, and a little bit bigger than Explorers, and we're 200 years old as a bank. So we were founded in like 1825. We're headquartered here in Cleveland, so welcome, and thanks for coming to one of our facilities here. If you see the tower downtown, everybody thinks we have all of the tower. We bought the branding rights to the tower. We're actually only in about 8 floors out of 57 floors in that building, and we don't even have the highest floor because a patent troll company said they wanted the highest floor, and they just sit up there in jeans and sue people for patent infringement. But we're about the 24th largest bank. We have a physical presence in about 15 states. But we also are a national bank now. We launched a national bank under the Laurel Road brand, especially around student loan, medical student loan refinancing, and that's a national bank. So just a couple fun facts. So I won't go through all these. This is like when we give talks to analysts, just so a lot of analysts know all the fun facts. But we have about 18,000 employees, about 5,700 contractors, 1,000 branches, 1,200 ATMs. We still have a mainframe, yes, and we do about 10 billion transactions a year on that mainframe. And as much as people think that the mainframe is going to die, you could have made a career just running COBOL your whole life and made a lot of money because there's less and less COBOL programmers. But that's just some of the landscape in terms of the size of the bank. We spend about $800 million a year on technology, so a little bit bigger than most startups. And we invest that in a lot of different tech. And we list a couple here. We do use low code. We use robotic process automation. We just launched an open banking API portal, so you can actually now go to keybank.com, and if you're registered with us, we'll open up our APIs, and you can do payments, wire transfers or ACH. We just launched that at Money 2020 in Vegas a couple weeks ago. We do have a big DevSecOps, so we are containerized. Almost all our digital properties run Kubernetes, and we're moving all of that to Google Cloud. We'll talk a little bit about Google Cloud in a minute. This cloud acceleration journey, we are migrating all of our distributed compute to Google. All of our data is already there, and a lot of our machine learning and data scientists are running out of Google now. If you're interested later, I'll be here, and if you want to know why we picked Google, I'll tell you that. But so far, it's been a good experience. And then, we're on a talent war, and we're all trying to attract and retain talent. And I think whether you're a startup or a large corporate, it's a tough job right now to keep talent. So I'll give you a short update on our journey to the cloud. So when I left Explorers, KeyBank wasn't using Hadoop, and I said, you guys got to get on this Hadoop thing, man. If you want to use big data, it's the latest hot thing. And Doug Kanoff is sitting over there, and I recruited him. He was working at Key, and I said, hey, Doug, you want to come work in the data team? He goes, I know nothing about data. I go, oh, don't worry, you'll learn. So he installed Hadoop. And the funny story is we were a big IBM shop, so we installed the IBM distribution of Hadoop, which then they gave to Hortonworks, which then merged with Cloudera. And so Doug's been through an IBM distro, Hortonworks distribution, now Cloudera Hortonworks. And we installed it, and we've got it up and running, and now his team is uninstalling it and getting rid of Hadoop. In the 9 years we've installed it, now we're uninstalling it. We did get rid of Teradata. I think when I spoke, we turned off Teradata a year and a half ago. And everything that was on Teradata is running up at Google now. So all of our data platform is up there. It does give us elastic scale-out compute, good pricing, high-performance compute, machine learning capabilities that we could have never put on premise. We never had the horsepower to do it. So that's just the general landscape. I say we're almost done. Doug says he's still got a long tail to shut off Hadoop on premise, but almost all the data we're running in parallel now up at Google. Installing Hadoop's hard. Getting off Hadoop takes just as much time. And now we have all kinds of cool metrics. This is just one of the dashboards. Everything at Google, you get a metric on. You can tell who's running what, how long it's running, what the cost is, what the compute cost is, what the storage. So we got all kinds of new dashboards that we never had. That's just good for Doug and his team to share with the business as to who's doing what and who's running expensive queries. So we run, it tells you how much terabytes have been scanned, how many queries have been run. We do have about 300 models too, machine learning models. I'd say most of those are legacy that were built on SAS, but a lot of the new models are being built in Python out at Google. And if you look at Google, there's lots of stuff at Google, just like AWS, just like Azure. There's lots and lots you can turn on. The big ones we're using are BigQuery, Google Cloud Storage, Compute Engine, Dataproc, which is Spark clusters under the Google name, Google Stack Driver, Identity Access Management, and support. We are a Tableau shop. We're also a SAS shop, and then Python out there too. Now that the data is there, a lot of our focus is on analytics. Like, what are the analytics teams doing? And to give you some metrics, we have about 400 SAS users, probably, the same number of machine learning data scientist people. And we're working now on, okay, what is going on in the modeling and AI and ML ops governance space? We really don't have ML ops, right? And so it's open space. Right now we're not really going at pure open source, but we are looking at, say, Vertex AI from Google. We're looking at Dataiku. We're looking at DataRobot in terms of working with the data scientists to say which one of these best fit the need of the corporation. That's just the general landscape before I get into data mesh and data mess. All right, so data mesh is a new term that's being marketed out in the industry. People are writing books about it, and I'm going to speak about that because Doug's a historian and he'll know some of the story. But at a high level, this is a simple map of our data supply chain and our data ops team. And I would argue that, Casey, that Doug has a good data ops team, right? We source about 150 systems into a data lake. There's about 3,500 tables there. And then from that, we move it into about 20 domain marts that are, I'd say, domain specific, business subject area specific. And then from there, it goes into the federated space, into the analytics areas. And we have about 70, in Google you call them projects, they'd be analytic workspaces in Teradata, where we let the business or the data scientists do whatever they want, right? So workspace, they can source data, they can run whatever they want, and they can use almost any tool they want. So I would call that federated, and there you're looking for speed, innovation, self-service. On the left-hand side, you're looking at what we would call our centralized data supply chain, which gives you kind of authoritative data sources, data governance, single source of the truth, aggregation, control balancing, tying out to the general ledger, and everything. When you get to the federated space, I call it a little bit of wild, wild west. If you produce something, you're basically certifying it's right. Now, the one big difference between us and Explorus, although, you know, Explorus was in the healthcare space, but if you're in a pure play startup, you're not regulated. Like, we are regulated. We're a bank. We're regulated by the OCC and the Fed. And they have a lot of restrictions on models, improvability of models, traceability of models, and then data lineage, data controls, and data integrity. And, you know, our CEO had said, hey, he doesn't hate the OCC or the Fed. It's the cost of being a bank. Like, they insure your deposits. So if you were in crypto and you lost all your money recently because they went bankrupt, you know, at least you're insured if you put your money in a bank. And there's a cost of that because the Fed will oversee you and govern you. So the Fed's starting to come in and saying, hey, in this federated space, what kind of governance do you have, right? And so I started calling this, if I can hide these controls so I can see my own. I started to come up with my own term. I'll call it the hybrid lake house mesh, right? And so take the best of data lake, data warehouse, data mesh, call it hybrid data lake house mesh, write a book, go on speaking tour, make a lot of money, right? And it's a little bit, if you go back in time, and I know Doug's probably the oldest, and you know the Bill Inman and Kimball wars from the 1990s, and I'm gonna get into that in a minute and tell you what I see. At a high level, I'd say Doug and his team, our data team, controls about 20 domain marts, right? Where they control the load of those, they control the integrity, they make sure they're valid. I'd call that maybe an enterprise data mesh where the data mesh has these, and I'll get into these 4 things. They talk about domain ownership, data governance, data as a product, and self-service. If you're in the enterprise space, I'd say we meet all of those other than self-service. Like, we're running it, we're centralized. When you get into the federated space, they really get into domain ownership. They don't do a lot of governance. They don't really do data as a product because they don't share what they build. They kind of keep it keep it to themselves. But they do meet the self-serve criteria. So you know, I think Doug wrote an article on the tension between governance and, you know, and non-governance, right? So at some point we'd say, hey, some governance is good. If you put too much governance in, none's going to get done. If you don't have any governance, the Fed and the OCC is going to come in and start harassing you. So we presented this to our executives and said, look, from the lake house, we feel pretty good. We've been inspected by the OCC and the Fed. We meet SOX controls. We have geo recon, blah, blah. And in certain areas of the bank, like in financial reporting, we have lots of governance. We meet our SOX controls. The Fed and the OCCs come in. In our models, like if you write a model key bank, you're getting governed because the Fed and OCC will come in. And so there's model risk governance. They'll validate your data. They'll validate your model. They'll validate you don't have bias. And so in those areas, we have pretty good governance. When you get to the 70 areas outside of that, almost no governance. Now, what the Fed is saying is, okay, outside of regulatory reporting, if you're giving a report to your board or your management and they're making decisions on it, how do you know it's accurate? Now, I can have all the controls on the data, and you can write one bad query in your report, and the report could be wrong. So validating a report is harder than actually validating the data. And so I keep saying the industry uses the term data governance, and I keep pushing people to say, you got to say data and analytics governance. Because I can govern the data, and you could have completely wrong reports. And if you're, right, and tying out the report's hard, because I can tie out the data, the GL, but to tie out your report, you know, if you made an inner join wrong, or outer join, or your model, like, you got to tie it out somewhere. So that's the space we're in. And now a little bit about data mesh. There's this lady called Zhamak Dehghani. She's now they're pinning her as the person who coined this term. She wrote a book. It just came out. If you want to learn more about it, it's $52. I'll give you the short story, but it does talk about these 4 principles: domain ownership, data as a product, self-serve data architecture, and federated computational governance. So she's pushing that you should not have central control. It should all be federated. Let every group do their own stuff, right? Now, my view is, and Doug's going to give me a clock here soon, right? This is Zhamak. She's speaking. She's writing books. She's at, you know, all these conferences. And she's like, oh, just align everything in a domain. Let those people have their own data engineers, source their own data, do their own data ops, write their own models that govern themselves. And I'm like, hey, this sounds familiar. I don't know. I'm probably the oldest person around here. Data as a product, it talks about, hey, each one of these units, they have their own data product team. They basically do their own metadata data management, their own data security. They write and ingest data. They publish their data, and they're self-contained. And that'll give you speed and agility and everything, right? And so, you know, you could say, think about the changes that this suggests. Data ownership transitions from centralized to decentralized. Architecture migrates from monolithic to distributed. Accountability is changed from top-down to federated, right? And I go back and I look at a couple pictures saying history always repeats itself, right? As long as people forget or they retire, then someone comes up with the same idea again. So 1990, building the data warehouse, right? Ralph Kimball or Bill Inman said, hey, you should build a data warehouse. Like, it's a single source of truth. Put everything in the data warehouse, and then from there, publish out to Mars. When I joined KeyBank 9 years ago, that's what Key was trying to do. Build a single giant data warehouse of everything that Key had. It was a disaster, and that's why they hired me from Explorers. And he said you can't put everything in one data model. It's just too complicated, right? And so Inman, or Ralph Kimball said, yeah, forget that. The data warehouse is just a logical thing. It's really the logical view over all these federated data marts, right? And so there was a big war in the 1990s between these two. They all both speaking, both wrote books, very difference of opinion. And you know, and Kimball would say, hey, look, or Inman would point to Kimball and say, this is crazy, because now every one of these people are sourcing data from the same spot. You're not getting a single source of truth. Everybody can make mistakes when they're sourcing. It's just a nightmare. It's M times N, like everybody's sourcing data all over, versus a data warehouse where everything goes into the data warehouse and goes out. But this one didn't work either, right? So I'm of the opinion that you got to find the best of both of those, right? And so when we actually say we're building a data lake, we don't actually put it into a single data model. We source it once from the source system. We logically assign those keys so they can be joined, and then we form domain-specific marts. But the challenge we're running into is in this federated space, there's very little governance over here. And so we're trying to find that happy medium between how do you govern in a federated space, how much governance you put, and how do they certify what they're doing is accurate when they produce. So we're going through this in models. We risk rank our models, right? High risk, medium, low risk. We're going to do the same with every analytics. Like, is this a board report? Okay, you got to have some governance, right? Simple thing like we're going to publish to Wall Street how many households Key has. That's not a model, right? It's just a report. But if you publish that wrong, people invest in your company that way. Your stock could go up and down based on how much you publish in terms of your household growth, right? And if you get it wrong, and so that was being built in a Tableau dashboard in a federated group. And right, we made a change to the householding algorithm, and it just blew up the report, right? And there's other stuff in that federated space. I'll tell you one other story. Somebody wrote a dashboard in Tableau that they were going to push out to 1,000 branches, and all it was how did the branch do last week, right? But if you have 1,000 branches that all log in at 8 in the morning on a Monday, and they run that report, and someone wrote that, sucking all this data into a Tableau server, trying to do multi-way joins, it crushed the server. So Tableau came in and said, we can solve that. Just buy more Tableau licenses, right? More cores. And it was going to cost us $1 million, right? And the head of the retail bank said, I'm not spending $1 million for a sales performance report. I'll send them an Excel spreadsheet. But that's what happens if you're not governing that federated space, because people can write bad queries, they can do bad models, they can publish bad reports. So just a weird space we're in. Like, I think the data space is actually easier when you get into this federated space in analytics. The governance tension gets really high, where like they want to do anything they want. And you're like, hey, we're a bank, we're regulated, and like some of this stuff has to be governed. And so that's the space we're in. So a couple takeaways that I just want to share with you. So I think this hybrid centralized, my lake house mesh, term I'll coin, write a book, go on a speaking circuit. I think data governance, people, every time I hear someone say data governance, I say, I think you mean data and analytics governance, right? Even the regulators, they say, oh, you need data governance. I go, I think we need analytic governance too, don't you? You need to find this balance between centralized and federated, and categorization of this to know what level of governance can I put on you. Like if you're just doing your own stuff, I don't have to put any governance. But if you're publishing something to Wall Street, I better put some governance on it and make sure you're publishing something accurate. And then how do you operationalize? Like, if you built something and we want to put it into a standard production work stream, do we all agree on what technology you're going to build in? And if I let every team build it in a different technology, it's very hard to operationalize. That's Doug's complaint. It's like, we can pick one, whether it's Python, or pick one MLOps tool, but I'm not going to pick 5 MLOps tools, right? And so trying to get that. Data security obviously is a big thing. Data lineage, data quality, data integrity, data accuracy. Data literacy is big. Helping data scientists figure out where the data is and where to source it from, that's a big problem. We've tried multiple tools in that space. It's still tribal knowledge. My son worked at Key for a couple of years in the machine learning, in the AI space, or in the reporting and analytics space. And he used to call me. He's like, Dad, where is this? And I called Doug, and I said, Doug, where is this? And Doug would say, it's in this mart, it's in this table, and here's access to it. I go, that doesn't scale well. Calling your dad does not scale. Like, I can't have that. But, you know, getting people to understand it is still a hard problem. So I'll stop there, and if you guys have any questions, I'll take them. My son left the bank and went to a crypto startup. But it's not a crypto startup, it's a crypto analytics startup, which is different than a crypto startup.
Thanks. Mike, what's the size of the data team? Like, can you just talk about like the size of your data architecture team, size of the governance team, size of?
Oh, the size?
Yeah, just given the maybe the.
So Doug here runs our data team. It's probably 350 people, and that's the data sourcing. That includes data governance. That includes the data lake build, the data mart builds. Anything else in that?
That's about it. Yeah, it's a team distributed across the United States. We've got a lot of consulting partners in India as well, operating multiple delivery centers in India and in Canada as well. So it's about 350. The demand continues to go up. Trying to find good talent and retain good talent is definitely one of our biggest challenges for sure.
That's in the IT side of the house. Then all of our analytics is federated on the business side, right? And they're not in one team. So they're like, our fraud has their own analytics. Our consumer bank does their own pricing and you know, targeted offers. Our commercial bank does their own analytics. So that's the problem, is we've got federated analytics and you're trying to like corral them, right? All right, back to you, Doug. One more question.
You mentioned consumer bank predictive scoring, so I'm curious, do you have that where you can predict whether a person who gets a key bank checking account opening for $300 if they're going to close it in 6 months or keep the account for 10 years?
There's a lot of, I mean, in banking, there's a lot of attrition modeling, there's a lot of acquisition modeling, there's a lot of next best offer modeling, right? And if you look at some of the models, I always say, predicting when someone is going to leave a bank, I don't need a model for. If they stop their direct payment into their checking account, it's a pretty likely event that they're going to, they're getting ready to leave the bank or they lost their job. But we have attrition models, acquisition models, next best product models, fraud models. Fraud is getting really, really tricky in Stripe window. It's getting debit card fraud, credit card fraud, prepaid card fraud. People are getting really smart, wire fraud. I used to say that when we open up our APIs to the public, the first people that will test them are hackers, right? They're going to test to see if you left anything open. Not our customers or not our partners, it's going to be hackers as soon as you open them up, right? Little do you know, like people didn't understand this. Our mobile app, most banks' mobile apps run off APIs. Like if you just reverse engineered our mobile app, it all calls APIs. Getting your balance is an API, getting transactions is an API, like it's all APIs, but we don't publish them. Now you have to authenticate first, but if you can get past the authentication, the APIs are available to call. Now we're publishing them, like mostly commercial, for commercial customers and fintech partners to use. And they're mostly wire and ACH, like payment processing APIs. All right, we'll be around. If I get another one there. Yes. Yep, we're at Apogee. We launched Google Apogee with the portal. We also stood up a Drupal portal out at Google for the front end and all the content management. We're a Kafka customer for a PubSub. Those are the big ones.
Great. Cool. Everybody give Mike a big round of applause. And again, I want to thank everybody for coming. It's great to see a crowd again in real life. I know the pandemic has it's been hard for everybody, and it's great to see the in-person community coming back together again. So January meetup, it's going to be at Cleveland State. If anybody has any suggestions on topics for 2023, please let me know. Anybody who wants to be a friend of the show, remember, it's a very valuable honorific. And again, always looking for new talent and new topics. So again, thank you for coming and stay around and hang out and talk. Thank you.